one more counter over there. So let's duplicate this empty counter and let's put it over there pointing to the side. So this one is on 7.5, 0, and -2. Okay, so now let's just make sure that they perfectly match. So let's put this one on a Z of -0.5. Okay, so let's test. Alright, so here we are, and look at that. And after 4 seconds, yep, there you go, it spawns the object. And then it immediately tried to spawn another one, and there you go, we have the error. Kitchen object parent already has a kitchen object. Basically, the way we designed our game and set up the code assumes that a single counter will only hold a single kitchen object. So we cannot have multiple plates on the same counter. Now, one solution for this problem is actually quite simple. When we spawn the plates, instead, let's not spawn a kitchen object. Instead, we're just going to spawn a dumb visual. Then when the player interacts with the counter, that is when we're going to spawn the proper kitchen object. So let's do that. Although again, let's keep the logic and the visual separate. So over here, let's first just handle the logic. So we just need to keep track of how many plates were spawned. So for that, let's store up here a private int for the plates spawned amount. And let's also do another private int for the plates spawned amount max. And let's say we can spawn at most 4 plates. Okay, so over here, instead of spawning the object, let's first of all actually reset the timer. So let's put it back to 0, 0. And on the plate spawned amount, let's check if this one is under the plate spawned max. And if so, let's go into the plate spawn amount and increase it by 1. Okay, so that's the logic, super simple. Now let's handle the visual. So let's first make our script. So let's create a brand new C# script for the plates counter visual. Now let's make sure to add the visual. So let's go inside the prefab, and over here we've got the visual. Let's attach it. Okay, open. Now here, basically the first thing we need is we need to know where to spawn the visuals. So let's actually add a reference to our counter top point. So let's add a serialized field for the private transform for the counter top point. Then let's also add a reference for the prefab we're going to spawn. So let's call it the plate visual prefab. Then here in the editor, let's drag the references. So the counter top point, place it in there. And for the plate visual prefab, let's go up here and find the visuals for the kitchen object. So these are just the visuals, and let's drag the plate visual. So the plate visual, not the plate kitchen object. Okay, now back in the code here, we obviously need to know when a plate is spawned. So let's go into the plates counter and make a nice event. So public event handler as usual, on plate spawned. And down here, let's just fire the event. So we just invoke with this and event.targs.empty. Okay, that's it, very simple. And then on the other script over here, let's just listen to it, which also means that we need a reference to our counter. So let's add over here the plates counter for the plates counter. So we're going to need to drag the reference, and then on start, let's listen to the on plate spawned event. And when that happens, then let's spawn. So let's call instantiate on the plate visual prefab. Let's put it inside the counter top point. So this is the transform for the plate visual transform. And that's pretty much it. Okay, so like this, it should be working. When the plate is spawned, we should be spawning a brand new visual. Back in the editor, we just need to drag the plates counter reference like that. Let's exit, save the prefab, and let's test. Okay, so here we are, and if we wait for 4 seconds, we should be able to see a plate spawn. Yep, there you go. And if we wait for a little bit more, we should also be able to see some more plates being spawned, except we can't really see them. That's because we're spawning them on the exact same spot every time. But if we pause the game, and over here look in the hierarchy and find the plates counter, and inside the counter top point, yep, we do have 4 visuals. And if we wait for longer, then nope, it's not going to spawn anymore. It's only going to spawn 4 plates. Okay, great. So to solve the visual, let's just offset them by a tiny bit. To know how much we should offset, let's keep track of how many plates have been spawned. So let's store up here on the visual script a list of game object. Call it the plate visual game object list. Let's also make sure to initialize this. So let's do on awake. Let's initialize this list. And then when we spawn them, okay, so here we have the object that we spawned. Now basically we just need to modify the local position. And let's put it on new vector 3. On the X, let's put it on 0. Then on the Z, we're also going to have 0. And then over here on the Y, let's offset it by a certain amount. And basically it's going to be based on how many plates have been spawned. So let's define up here a float for the plate offset Y. Let's put it at, say, 0.1f. And over here, we're going to offset it by this much, multiplied by how many plates have been spawned. So we can go into our visual list.count. So you can do it like this, and then we just need to add it to the list. So let's add this plate visual transform.game object. Okay, so now each game object should be spawned at a different height. So let's see. So here we are, and if we wait for 4 seconds, we should be able to see a plate, and there you go. And now after 4 seconds, we should be able to see another one placed slightly above, and yep, there it is. Okay, great. So everything is spawning perfectly, both in the logic as well as the visual. Now let's actually pick up a plate. So on the plates counter, as usual, let's implement the interact. So let's do a public, let's override the interact function. And now for picking up, let's first see if the player is actually empty-handed. So if, and we check the player has kitchen object. So if the player does not have a kitchen object, then the player is empty-handed. Okay, great. Then let's see if we have a plate that we can give them. So if the plate spawned amount, if it is bigger than 0, then there's at least one plate here. And if so, let's give it to the player. So how we do that is, well, over here for the logic, let's just increase it by 1. Then let's actually spawn the object. So on the kitchen object, let's spawn the plate kitchen object SO and spawn it on the player. And finally, we just need to update the visuals. So let's make another event. So up here on plate spawned and on plate removed. Okay, we have this event. And then down here, let's just, whenever the player picks it up, let's invoke this with this and event args.empty. Okay, great. So now on the visual, let's listen to this. So we're here on start for the plates counter, listen to this event. And when this event happens, we just want to destroy the very last plate. So let's grab the game object for the plate game object. And we're basically just going to go into our list. So the plate visual game object list. And let's pick up the very last one. So let's go into the list.count -1. So this is going to be the very last element of the list. Then let's remove this one from the list. So plate.remove this one that we just grabbed. And then we simply call destroy on this one. All right, so that's it, super simple. So over here on the plates counter, we do all of our checks. We cut it down by 1. We spawn the actual kitchen object and we fire the event. And over here, the event listens and updates the visual. Okay, let's test. So here we are, let's wait for a plate to be spawned. And when it's spawned, there it is. I'm going to pick it up. And yep, there you go, the player is now carrying a plate. Let's drop it here. And there you go, there's another one. Now let's wait for a bunch more to be spawned. Okay, so the plates counter is full. Now if I pick up, it should only eliminate the last visual. Pick it up, and yep, there you go, it'll eliminate that one. Now I can drop it in there, and yep, there you go, another one spawn. All right, awesome. Okay, so that's really it for the basics of the plate counter. It periodically spawns some plates, which the player can then pick up. Now in the next lecture, we're going to add the ability for the player to be holding a plate and pick up another object onto the plate. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to add the ability for the player to be carrying a plate and pick up objects onto that plate. Okay, so here we already have the plate counter working. It has some basic logic. After a bunch of time, it spawns a plate. It spawns up to a certain maximum. And I can pick up a plate, and yep, the player is carrying a plate, so I can put it anywhere. Then I can, for example, pick up some tomatoes, slice them, and pick them up. However, now I am not able to place the tomatoes on the plate. So let's add that logic. Let's begin over here on the clear counter script. First, we're testing if there's no kitchen object here, and the player is carrying something, that the player drops something in there. But then we're testing if there is a kitchen object here, and if the player is carrying something. So it's over here that we want to check if the something that the player is carrying, if it is a plate. Now our plate is also going to have a bit of custom logic. So to help both identify and hold that custom logic, let's make a proper script to handle it. So back in Unity, let's create a brand new script. Call it the plate kitchen object, and let's open this. Now over here on this one, instead of extending mono behavior, we're going to extend kitchen object. So the plate is really just a more specific type of a kitchen object. Again, like I mentioned quite a while ago, you want to be very careful with inheritance. You need to have a very good reason to do it. Here we want the plate to behave exactly like a kitchen object, just with a tiny bit of extra logic, so in this case it makes perfect sense. Let's just go ahead and save this. And wait for Unity to compile. And over here, let's find our kitchen object with the plate. So here it is, the prefab. As you can see, we have a kitchen object. Now, instead of having that one, let's replace that with the plate kitchen object. And since we are extending kitchen object, we have the same fields. So let's make sure to add the kitchen object SO and get rid of the other one. Okay, great. So now back here on the clear counter, when there is a kitchen object here and the player is carrying something, we can check if the player is holding a plate, and for that we can check the type. So if, let's go into the player, and let's get the kitchen object the player is holding, and we test if this object is of type plate kitchen object. If so, then that means player is holding a plate. And if that is the case, then we basically want to give the player whatever object is over here, we want to add it to the plate. So let's go into the plate script to add that function. So over here, let's make a public void. Let's call it add ingredient. As a parameter, we're going to receive a kitchen object SO. We really only care about the type. We're going to destroy the actual kitchen object like we've been doing when creating different types. So the plate is really just going to store a list of types. So up here, let's store a list of kitchen object SO for the kitchen object SO list. Then when we add the ingredient, let's just add it to the list. So this kitchen object SO. Let's also make sure to initialize the list. So let's do it on awake. Let's initialize our list. And now from the other side, we just need to call this. So over here on the clear counter, if the player is holding a plate, let's first get the type of plate. So plate kitchen object or the plate kitchen object. We go into the player to get the kitchen object and we cast this as a plate kitchen object. Okay, so we have this, and then over here, let's call add ingredient and let's add whatever is currently on this counter. So let's get the kitchen object and get the kitchen object SO. Okay, so we're adding it to the plate, and then let's destroy what is here. So get kitchen object and destroy itself. Okay, so that's it. So if there is something here, and if the player is holding something, and that something the player is holding is a plate, if so, we're going to add that ingredient to the plate and then destroy the object in here. So let's test. Okay, so here let's pick up a tomato, let's slice it, let's put it on a clear kitchen counter because that's the only one where we added the logic. So on this one, let's pick up a plate, and now whilst I'm carrying the plate, and if I approach and I interact with it, and yep, there you go, it does work. The object vanished from the counter and supposedly was added to the plate. Again, we can use a really nice debug inspector to see it. So let's pause the game, let's select the plate, let's see the plate kitchen object, so here it is, this one, and let's change the inspector into debug mode, and down here, yep, we do see the kitchen object SO list, and it does have some tomato slices. Okay, awesome. So with this here, we have our basics. We can have some ingredient, and we can basically pick it up from a plate. Now, one thing about our plate, this is where we're basically going to carry the final recipe that we're going to deliver to the customers. And based on the design that I defined, I want something pretty simple, meaning for the design that I'm going for, there won't be any kind of double burgers or double cheese. So each final recipe will only have at most one of each ingredient. So let's add some basic logic just to prevent adding duplicates. Over here on the plate kitchen object, when we add an ingredient, since the function will now not necessarily succeed every time, let's actually rename this. And again, use the very useful Visual Studio shortcut. So you can press Ctrl+RR or right click and let's rename. Since this function will no longer succeed, we're just going to try to add an ingredient. So try add ingredient. And then let's also make it return a boolean. Basically for any function where you're not sure if it will succeed, I like to add try and make it return bool. So this way it works pretty much exactly like the try again component that we've already seen so many times. So it tries to do something and returns whether it succeeds or not. So over here, instead of always adding the ingredient, let's see if this one is a duplicate. So let's do an if, and let's go into the list and check if the contains, and if the list already contains this kitchen object SO. If though, then already has this type, so let's return false. And if not, then that means this is a brand new ingredient. So let's add it and return true. Okay, so that's it. Now let's go over here onto the clear counter. So we try to add the ingredient, but then we only want to destroy if this one succeeds. So let's put this one inside an if. So if we do manage to add the ingredient, then yes, let's destroy itself. If not, then we don't destroy anything. Okay, so let's test. So let's go ahead and slice 2 tomatoes. So one, slice it, put it here. Then another one, slice it and put it here. Now let's pick up a plate, go up here, try to pick up this one, and yep, it does work. Now for this one, and nope, it doesn't work. Okay, great. Now one more thing in our logic, we only want to pick up certain things. Like I said, only things that won't be used in the final recipe. For example, no customer is ever going to request a full entire tomato. The recipes only have sliced tomatoes, so we should not be able to drop a full tomato directly on top of a plate. So let's change that. So over here on the plate script, let's basically just create a list of our valid ingredients. So let's make a serialized field, private, make it a list of kitchen object SO, and call it the valid kitchen object SO list. Okay, so we have this list. And over here in the editor, let's just drag the ones that we want. So let's first of all select the plate object. Okay, here is the plate prefab. And over here we've got all of our kitchen objects. So let's just drag the ones that we want to add to the plate. So the final recipes will have some bread, yep. But they will not have entire cabbages, they will only have cabbage slices. Same thing, no cheese, only slices. For the meat, we're only going to be able to add meat cooked, but also meat burned. Then we're not going to be able to add a plate onto a plate, of course not. And finally, instead of a tomato, just tomato slices. Okay, that's our valid list. And over here, again, it's very simple. So we can just go, if the valid kitchen object is a list, if this one contains the one that we want to add, then we can add it, but if not, then let's return false, not a valid ingredient. Okay, so let's test. All right, so let's pick up a tomato and also some tomato slices. And now if I pick up a plate and I go into the tomato, nope, doesn't work, but the slices, yep, it does work. Okay, great. So here we have all of our basic plate rules. Everything is working perfectly, but it's only working over here with the clear counter. So let's do a little bit of code cleanup, and then let's add this logic to all the other counters. So first, to clean up this code, over here we are testing if this is a plate kitchen object. Then we cast to an object, and then we call the function. So let's simplify all of this. And let's do it just like Unity does with their try_get_component function. So let's make a custom function that takes an output parameter. The best place to put it is on the kitchen object. So here we've got the kitchen object script. Okay, great. Let's scroll down and make a nice function here. So let's make a public. We're going to return boolean in case this succeeds or not. Let's call it try_get_plate. And over here, let's make an out parameter. So don't forget the out keyword. Let's return of type plate kitchen object for the plate kitchen object. And over here, we do exactly what we did. So we test if this object is a plate kitchen object. If so, then let's set the plate kitchen object equals this as a plate kitchen object. And we return true. But if not, then this is not a plate. So let's return false. And one thing when working with output parameters, you always need to make sure to set the output before you exit the function. So over here, that's the error that it's telling us. We must assign it to something when we return. So over here, we don't have a plate kitchen object. So to solve this, we just set this to null. Okay, great. Now over here on the clear counter, instead of doing all of this, basically let's ask the player if this is a kitchen object. So let's try to get the plate. Out plate kitchen object for the plate kitchen object. So you try to get it, then we try to add the ingredient, and so on. Now obviously we could further simplify things by making a function that would try to get the plate and try to add the ingredient. That could work, but since some counters are going to have a bit more custom logic, I think keeping them separate like this makes more sense. So first we try to get the plate, then we try to add the ingredients. So let's apply the same logic to the cutting counter. So over here on the cutting counter, let's scroll down to where there is a kitchen object here and the plate is carrying something. So on the clear counter, we just want to copy all of this. So let's go over here and we do the exact same thing. Okay, that's it. And the other counter from where we can pick up things is from the stove counter. So here we are on the stove. Let's scroll down until we find the interaction. Okay, there's something here. The player's carrying something. So it's over here. Let's do that and do the exact same thing. Except on the stove, again, let's remember that this is using a state machine. So when we pick up something, let's do pretty much the same thing that we did here. So let's make sure to reset the state, fire the events, and so on. Okay, so those are the only counters that we need to implement. We cannot drop things on top of a container. We cannot drop things on top of the plate counter or the trash. So these are the only three types that we need to implement. So with this, let's test. Okay, so let's begin with some meat. So let's pick up some meat, put it on the stove. Let's pick up a plate, wait for it to cook, pick it up, and yep, there you go, it does work. Now let's test the cutting counter. So let's pick up some cheese, let's slice it, pick up some plate, and go, and yep, there you go, it does work. And again, if we inspect, we can make sure that it is indeed working. So let's go into the plate. And let's put this on debug inspector, and yep, there we do see this one has a meat patty cooked and some cheese slices. Okay, great. Now the last piece of logic that we need is pretty much the opposite. So right now it works if there's a sliced object on the plate and the player is holding a plate object. But now we want the opposite. So let's say there's a plate in here and we slice some cheese, and now I want to drop the cheese on the plate. So let's do that. And basically for this one is only going to happen on the clear counter. That's the only counter type that can have a plate on top of it. So over here on the clear counter, then we check if there's no object there, but that's not what we want. We want if there's a plate on the counter. So if there is an object there, and if the player is carrying something, then we check if the player is holding a plate. But if not, so if the player is not holding a plate, So player is not carrying plate, but something else. Over here, we need pretty much the exact same logic, except just testing for the object on this counter. So let's do if, let's get the kitchen object on this counter. This one tried to get the plate. So out plate kitchen object for the plate kitchen object. So if so, there's a plate over here. That means the counter is holding a plate. So then let's go into this plate kitchen object. Let's add the ingredient. And we're going to try to add whatever the player is currently carrying. So the player dot get kitchen object and get the kitchen object SO. So we're going to try to add this. And if we can't add, then we're just going to destroy whatever is on the player. Okay, that's it. And over here we've got a nice error just because we defined it with the same name up here. So up here we're already defining the variable, and over here we're defining the same variable with the same name. So we can either give this a different name or just not define a brand new variable here. So just it's defined up here and we're using it here. Okay, so all logic is working. Now here, make very sure that you're not mixing references. Keep in mind when you're referencing the kitchen object on this counter and the one on the player. Those are two different things. So over here, if the player is not carrying a plate but something else, then you check the kitchen counter. So over here, you're not checking the player but checking the counter. Then you go into that plate and you try to add the ingredient and you try to add the one that the player is carrying, and then you destroy the one the player is carrying. So again, be very careful here. Make sure you don't mix references. So with this, it should work. So let's make sure to save our script and let's test. Okay, so here we are. Let's first pick up a nice plate. Let's drop the plate in there, pick up some bread, drop the bread, and yep, there you go, it does work. Alright, so now we can do a bit more natural interactions. So for example, let's pick up some meat and put it on cooking. And there you go, the meat is fried, so now I'm currently carrying just some meat. So I place it there, then I pick up some bread and put some bread on top of the meat. And yep, everything does work flawlessly. Okay, so here we created a plate, and we created some custom logic to define what the plate can and cannot pick up. Now all that's left is actually being able to see what is on the plate, so let's do that in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture we're going to add a nice visual to our plate. Okay, so right now we can already pick up ingredients onto the plate, so if I pick up the plate and I pick up some cheese, there you go, there's some cheese on the plate, but we cannot see it, so let's solve that. And the way we're going to do that is actually in a very simple way. If you look in the included assets inside the prefab visuals, there's this nice plate complete visual that I built. Basically, it's a full burger that contains all of the ingredients. What we're going to do is actually very simple. We're just going to enable or disable these game objects. That's it. So let's do exactly that. Let's make a new C# script. Call it the plate complete visual. Let's attach the script over here. And let's also make sure to put this one inside the plate. So let's save this prefab. Let's go inside the plate prefab. So inside the prefabs, here the kitchen objects, we've got the plate. So inside the plate, let's drag that. Let's drag the plate complete visual. Okay, great. So now let's open up this script. Over here, let's first add a reference to our plate kitchen object. So a serialized field, private for the plate kitchen object for the plate kitchen object. Back in the editor, let's drag the reference. Okay, great. So now here, basically, we need to update this visual whenever the plate gets any ingredient added to it. So let's go over here into the plate script and basically just need to fire off an event when that happens. So let's make a public event handler, and let's call it on ingredient added. Okay, and for this one, let's also make an event args to contain the data of what object we added. So let's make a public class on ingredient added event args. Let's extend event args. And inside, let's make just a kitchen object SO, kitchen object SO. Okay, great. And let's make the event of this type. All right, so now let's just fire off this event. So down here, when we try to add an ingredient, if we do add the ingredient, let's fire off this event. So let's invoke with this, and let's create a brand new one, passing the kitchen object SO as this kitchen object SO. Okay, so we have our event correctly being sent. Now over here on the plate complete visual, let's listen to it. Again, as always, let's make sure to do it only on start. So the plate kitchen object on ingredient added, let's listen to this event. And over here, we just need to either enable or disable the visuals that relate to the kitchen object inside over here, the event args. However, of course, the question is, how exactly do we find them? The plate complete visual has all of these game objects. How do we know which one belongs to that kitchen object? Now, technically, one way would be to do a simple transform find and find the child objects by name. Technically, that would work, But like I mentioned in the beginning of the course, strings are a horrible way to identify things. They are very error prone. So let's not do that. Instead, let's use a proper approach where we can define some kind of link between a kitchen object SO and a game object. And we can do that very easily by just defining a struct. So up here in our script, let's do exactly that. Let's define a public, make it a struct, and name it kitchen object SO underscore game object. Then inside, it's very simple. We just have a kitchen object SO field, and then also a game object field. That's it, super simple. By the way, if you don't know what is a struct, basically it's very similar to a class, except it's stored in different places in memory and behaves somewhat differently. I have a very important video on that subject, what is the difference between value types and reference types. Classes are reference types, so when you pass in a class into a parameter, you are passing in a reference to that object, whereas structs are value types, so when you pass in a struct onto a parameter, you are passing in a copy. It's a bit of a tricky thing, so definitely make sure you go watch that video for more detail so you don't get confused in the future. Here I defined it as a struct simply as kind of a teaching moment, but also because it just makes sense that if I just want to store some data without any logic, then it should probably be a struct and not a class. Although in this case a class would work just as well. Anyway, so here we have a struct. Inside the struct we have a field of type kitchen object SO and another one of type game object. So now let's just make a list of this type that we can expose in the editor. So up here, a serialized field, private, let's make it a list of kitchen object SO game object and call it kitchen object SO game object list. Okay, that's it, super simple. So let's save and make sure this compiles. So actually, let's just comment this out, just make sure our code compiles, okay? And over here in the editor, we see the tricky thing when it comes to using fields of custom types. If we look in the inspector, nope, we don't see anything, so we cannot see our custom type in the inspector. If you make a custom type like this struct, and you want to show it in the inspector, then you need to add the attribute serializable, which exists inside system. So let's go up here using system, and let's add the attribute serializable, just like this. Okay, so do this, save, and let's look. And if there we go, now we do see our custom struct. So we've got a list, and we can click on the plus icon, and there you go, we've got an element, and it does have a field for a kitchen object SO and one for a game object. So that's great. With this now we have a really nice place where we can link one object to another. So let's just do exactly that. So for example, let's put the bread over there, and let's assign the kitchen object SO for the one with bread. Let's do the same thing for all of the others. So let's add a whole bunch more. Okay, so we've got the bread, then we're going to have the meat patty cooked, then the tomato slices, then we have the cheese slices, the cabbage sliced, and finally the meat patty burned. So we've got numbers 0 through 5, so we have 6 elements, and over here, yep, we do got 6, so we have all of them. We can get rid of these last 2, okay, great. And now let's assign the proper objects, so this one for the meat patty cooked, then we've got the tomato slices, then we have the cheese slices, then the cabbage slices, and finally the meat patty burned. Okay, great, so all of the references match. Now back in the code here, so we have this list fully filled out. And when we have this, it's really very simple. We just cycle through the list to find the right game object. So let's do a for each of type kitchen object SO game object in our kitchen object SO game object list. And we check if this kitchen object SO dot kitchen object matches the one that we received in the event. If they do match, then go into this one, grab the game object, and set active into true. Okay, so that's it, some very simple logic. And also we can start with them disabled by default in the editor, or just over here, just do something very simple. Just do a for each, cycle through every single one of them, and set every single one of them to false, so that they are hidden. Okay, so with this, all the ingredients on the plate should be visible. So here in the editor, let's just make sure all the references have been set. Let's go back, save the prefab, and let's set on play. Okay, so here we are, and by default, look at that, an empty plate, and yep, it is empty. And now let's slice some cheese. Now let's place some cheese on there, and yep, there you go, we've got some cheese. Now let's pick up some bread, drop some bread, and there you go, got some cheese and some bread. Then let's cook some meat. So let's cook it, and let's pick it up with a plate. And as soon as I go, boom, there you go, I've got a nice cheeseburger. All right, awesome. So with this, I can now do a complete burger, so let's finish it. Let's just add some more tomatoes, so slice them and add the tomatoes. And finally some sliced cabbages, slice them, put them there, and there you go, here we have a fully complete burger. Okay, so that's great. All of our visual logic is indeed working. However, this visual is a bit hard to see. It's not very clear to the player. So just looking at it from this distance, does that have a tomato or not? There's a tiny sliver of red in there, but you can't really see it. So we should probably add some nice clear icons on top to clearly indicate what exactly is on this plate. So that's exactly what we're going to do in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture we're going to add some really nice icons on top of our plate so we can easily see what is on there. Okay, so for the icons, let's do the exact same thing that we did for the progress bar, meaning let's use a world space canvas. So let's go inside our plate kitchen object prefab, and over here let's right click, let's create a brand new canvas. Let's name this the plate icons UI. Then for the settings, let's make it world space, put it on 0, 0, everything, width and height also on 0. Then let's lift it up a little bit, so put it on a Y of 1, okay, like that. Now inside, let's define an icon. So let's start by making an empty game object, call this just the icon template. Let's put it with a size of 0.3.3, so okay, something like that. Then inside, let's add a new UI image, name this the background, and make it stretch to fill the parent, so put 0 on everything. Okay, there's our background. For the background image, instead of a square, let's actually go with a circle. For that, Unity actually has a bunch of built-in sprites that it added in the last versions. However, it's not actually over here by default. In order to see those default sprites, we need to install the 2D sprite package. So let's quickly just go into Window, Package Manager. Let's make sure we are in the Unity registry, make sure we are looking at all. And over here, let's find the 2D sprite package. Okay, so let's install this. Okay, there's the package. So now if we go into the background and we search for a sprite, and over here, make sure you click to actually show the assets from the packages. And now we see a bunch of default hexagons, a bunch of isometric tiles, a square, so on. And if we search for a circle, yep, here we've got a bunch of circles. So let's use this one over here on this path, so let's use it. There you go, we have a nice circle. Now let's duplicate this image, and for the second one, let's name it icon. And for this one, let's assign just a random sprite, so let's say the bread. And again, remember how the sorting order on the UI, this one is based on the order in the hierarchy. So make sure that the icon is underneath the background in the hierarchy, that way it shows up on top. Okay, so we have our icon template, that's great. Of course, we're going to dynamically generate all of this through code. We're going to have multiple icons, and for positioning them, Unity actually has some really useful components. Let's select the plate icons UI, and over here let's add a component. Now for example, a built-in component is the grid layout group. This basically helps you position all of the child objects. So let's put the size of the canvas over here on 0.9.9. Okay, so there you go, a nice square window. Then over here on the settings for this, for the cell size, let's put it at 0.3.3. And if there you go, already shows up over there on the corner. And we can see what it will look like if we just duplicate this object. So let's make a bunch more templates. And if there you go, that's what it looks like. So as you can see, this component is super useful for automatically positioning all of the child objects. Now if we want, we can play around all of these. We can add a little bit of spacing on the X or on the Y. But let's actually leave both those with 0. Let's leave everything on defaults. Just over here on the child alignment, let's put it on middle center. Okay, so there you go. That looks pretty nice. So you can see how this built-in component is super useful. There's actually two more. So this one for the grid layout, this is great when you want to put things horizontally and vertically. But if you just want horizontally, then there is the horizontal layout group. And if you just want vertically, there's the vertical layout group. So all of these components are really awesome, really useful. Okay, so with this, our objects are placed. And note how I named this an icon template. Basically, a template is just what I call something that is kind of like a prefab, but not really a prefab. Through code, we're going to duplicate this template and dynamically modify the icon. So we're going to use it very much like a prefab. We could actually make this into a proper prefab. So I could just drag it over here onto the project files and make a regular prefab. That could work. And the only reason why I prefer this method of not using a prefab is just because this object, this template, stays here on the object as opposed to cluttering over here your project files. If you have tons of single-use UI elements with tons of objects you need to spawn, you can end up with tons and tons of prefabs, and you might not even know where each of those is used. Whereas with this method, the template stays exactly where it's used and does not take an asset slot over here on the project files. So personally, this is just the approach that I prefer for spawning UI elements, but like I said, prefabs work as well, so if you prefer using prefabs, go ahead and make it. Okay, so let's make our script to run the plate icons UI. So let's go into our scripts, and on the scripts folder, let's create a brand new C# script for the plate icons UI. Over here, let's attach a script and open it. Okay, so now the first thing we need is a reference to our plate. So let's begin by making a serialized field private for the plate kitchen object for our plate kitchen object. Okay, let's save it and drag the reference. So over here, there's the plate icons. Let's just drag the plate reference. Okay, great. Now on the plate, we already made this event when an ingredient is added. So basically, we just need to listen to this in order to add the new icon. So over here on the UI, let's do, as usual, private void start. And on start, let's go into the plate kitchen object and listen to that event. And when that happens, let's spawn an icon. Although here, let's actually use a different method from the one we used on the plate visual. Over here on the plate visual, whenever we had the event, we really just modified the object that was added. So over here, the equivalent would be to spawn a new icon whenever that one was added. But instead of doing that, right now let's listen to this event, and when this happens, let's update all the icons in this display. Basically, this other method is useful when the contents can be added as well as removed. Now in this case, they are never going to be removed, so in this case, both methods work fine, but still I want to show you the second method just so you can use it when you need it. So for that method, we just need to know exactly what is on the plate. So over here on the plate kitchen object, we just need to expose the kitchen object SO list. So let's do exactly that. So public, we're going to return a list of kitchen object SO. Let's call it get kitchen object SO list. And we just return the kitchen object SO list. Okay, very simple. Then over here on the plate icons UI, let's just make a function to update the visuals. So private void, let's call it update visual. And when we have the event, let's call our update visual. Okay. So now here, let's basically just cycle through all the ingredients. So let's do a for each kitchen object SO in the plate and get the kitchen object SO list. Okay, so we're cycling through all of the ingredients on the plate. And then we want to duplicate our template. So that means we need a reference up here. So let's add a serialized field, private, type transform, call it the icon template. Okay, and let's save the code. And over here in the editor, let's drag the reference. So let's drag the icon template. By the way, I left the others over here. That's not a problem since these are going to be destroyed, those we're going to see in a little bit. The only one that matters is the first one. Okay, so here we have the icon template. So to spawn it, we do it just like we do with any prefab. So we just call instantiate, pass in the icon template, and then transform parent. So let's put it as a child of this object. This part is important. We need to make sure the object is spawned as a child of this object. If over here you put something like null, then the template won't be spawned as a global object, so it won't be somewhere in the world. So in order to make it positioned properly, let's make sure to use transform to become a child of this object. Okay, and then since we're using the other script, the grid layout group, this is already going to be automatically positioned. So just like this, it should be spawning the icon. And with the icon spawned, all that's left is really just setting the image. And now again, the quick and dirty approach would be over here when we spawn. Let's say we pick up the item transform. And over here, we could go inside and do a find in order to find the image, in order to get the component of type image and so on. So that is one approach. That would be the quick and dirty approach. But again, we want to do things properly. So let's do it the proper way instead. So instead of this, let's make a proper script that we're going to run on the icon template. So let's create a new script. So a new C# script, call it the plate icon single UI. So this one represents just a single icon. Let's go ahead and attach it to the template. So over here, let's drag it. And now when using this template method, really the only one we need to worry about is this one. The other duplicates, we can just leave them. They don't really matter. But still, just to avoid confusion, I'm actually going to delete them. So okay, we just have one icon template, okay, and it has our script. Okay, let's open. Now over here, let's basically just make a function to set a kitchen object SO. So public void, let's call set kitchen object SO. And we receive parameter of type kitchen object SO. Okay, great. So then we need to set the image. So let's just go into a serialized field, private of type image, which is inside unityengine.ui. So for this one, for the image, we have a reference, and then we set the image.sprite, go into the kitchen object and grab the sprite. Okay, so all we need to do is drag this reference. So over here in our template, let's drag the icon image. Okay, great. So now back here on the plate icons UI, so we spawn it, that's great. Then let's do a get component in order to get our script. So the plate icon single UI, okay. And then we just call set kitchen object SO and pass in this. Okay, that's great. This is much better. Now again, you might be thinking that this method is a lot more verbose than just setting the image sprite here. We had to create another completely new script. We had to write this logic and over here get it and use it. The quick and dirty approach would indeed be quicker, but remember that while the quick and dirty approach might be faster at first, it will mess you up over time. So just take a few extra seconds to do things properly. This approach is much more scalable. Let's say, for example, on this function, you want to change not just the sprite, but also trigger some kind of spawn effect or animation. With this, it's very simple. We've got this function right here. We receive the kitchen object SO, and we can do whatever we want with it. So like this, we have this script that is responsible for anything related to the single template. And we've got the general one, which just spawns them and just gives them the kitchen object SO. So all of our logic is nicely separated. Okay, so just like this, it should already work. However, like this, you might already be thinking, won't this spawn way too many icons? And yep, it will. Basically, every time we add an ingredient, we're updating the visual, where we're cycling through every single one and spawning all of them. So with this, we're constantly going to spawn more and more items. This is not what we want. Over here on the update visual, we do want to update and spawn all of the icons, but before we do that, we actually need to clean it up. We need to clean up the icons from the previous event. So before we do that, let's just cycle through all the children on this transform. So that's pretty simple. You can just do a for each transform child in the transform. So this way cycles through all the children, and then just call destroy on this child.gameObject. So that won't work. That won't destroy all of the previous children. However, of course, we also have one issue. The icon template itself is also a child. So if we do this, we're going to destroy the icon template, which then over here we're going to have an error because we're going to instantiate null. So we want to destroy all the children except for the template. So over here, that's pretty simple. We just check if the child equals the icon template. If so, then let's just skip it. So we can just call continue, and there you go, it skips. Okay, great. So just one more final thing. If we leave the template like this, meaning the game object is enabled, like this, the template will always be visible plus whatever ingredients we have. We don't really want the template to be visible. This is just meant to be a template that we can instantiate. So that's pretty simple to fix. Let's make a private void awake, and on awake, let's grab the icon template, grab the game object, set active into false. Okay, so now the icon template won't be disabled, so it won't be visible. And then over here, when we are instantiating, the instantiated ones will also be disabled. So let's make sure we go in there and enable these. All right, that should do it. So all of our logic should be working. There's only one more tiny thing we need to take care of. This one is a world canvas. So like we saw with the progress bar, we need extra logic to make it look towards the camera. And thankfully, we already wrote an excellent generic script to do just that. So let's go into the plate icons UI, and let's add a component, and let's add our very nice look at camera. So like this, and let's set the mode the same that we use, so let's put it camera.forward. Okay, so everything is great, everything should be perfect, so let's finally test. Let's leave the scene, save the prefab, and hit on play. Alright, so let's go pick up a plate, and there you go, there are no icons visible. Okay, that's great. Now I'm going to place a bread on top of the plate, and there you go, I've got a nice bread icon. Okay, great, now let's make some meat, cook it, and as soon as it's done, I'm going to pick it up, and there you go, I've got a bread and some meat. Now let's put some cheese, slice it, put it there, and there you go. Now I can easily see that plate has some bread, some meat, and some cheese. Now let's just add the rest of the ingredients to make a full mega burger. So let's add some tomatoes and add some nice cabbage slices. And yep, there you go, it works perfectly. So here we have a complete burger with everything, and we can easily see on the icons everything this contains. Alright, awesome! Okay, so here you'll learn how to make yet another super useful element that you can easily add to all of your games. Personally, I use this kind of logic a ton in all kinds of UI things. For example, in my upcoming Steam game, Total War Liberation, the items in the inventory, they're all added using this method. So there's a template and I duplicate that template. Same thing for all of the action buttons. All of those are based on having a template and duplicating it. It's a really easy way to do this kind of thing. With all of that, here we have a full plate and we can easily see what is on there. So with this, the next obvious step is to actually deliver some orders. So let's do that in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture we're going to build the delivery counter. This is where we're going to drop some items that the customers have requested in order to complete the orders. Also, just for fun, we're going to learn how to use ShaderGraph to make a simple custom shader. Okay, so let's begin by making our counter. So let's go into our base counter, let's create a new prefab variant for delivery counter. Let's go inside, and now let's find the visual, the visual for delivery counter. Let's duplicate it to make the selected. Let's go inside, modify the material. Then on the selected, make it 1% bigger, 101, add the component, the selected counter visual. Let's drag the kitchen counter like that. Okay, that's our basic setup. And also start with the kitchen counter disabled. Okay, great. Now let's make a script to run this. So let's go into our counters folder. Let's create a brand new C# script for the delivery counter. Let's attach it and open. Okay, so now here as usual, let's begin by extending our base counter class. All right. Now let's override the interact function. And for now, let's actually do it exactly like the trash counter, meaning let's just destroy the object. So we just check if the player is holding something. So if the player has a kitchen object, let's go into the player, the kitchen object, and let's destroy it. However, another rule over here for the delivery counter is this is only going to accept plates. So let's see if the player is carrying a plate object. So player get kitchen object and test, try to get the plate. So out plate kitchen object for the plate kitchen object. We try to get this, and if it is a plate, then we destroy it. Okay, that's it. Here in the editor, let's just compile the script and drag the references. So the counter top point, and on the selected, let's drag the counter reference, and let's exit this, save the prefab, and let's drop it over here on the corner. So let's find over here the delivery counter, and let's put it over there. Angle it on this side, put it like this. Let's also just quickly reposition all of our counters, since we already have all of the types that we're going to use. So on delivery counter, let's put it over here on this corner, so X 7.5, 0, and Z of 2. Then next to it, let's put the plates counter, so over there, okay. Then next to it, let's put a clear counter. After that, let's put the trash counter. And then let's also put another empty one there, so let's duplicate this one. Move it up to about this, and put it like that. Now we just need to move all of these down here. So just select all of these counters and let's move them down by about this. Okay, so on minus 5.5 like this. Okay, so everything is nicely positioned. Just over there right now we cannot access that container, so let's actually modify those as well. Which, by the way, over here there's the canvas in front, so as I click, I'm actually selecting the canvas in the hierarchy. So here's a quick inti tip. On the hierarchy, on the left side, you've got these two buttons. So one of them hides the object and the other one simply makes it unselectable. So if I click on this and I click through, any of the click goes through the canvas. So that makes it much easier to select over here all the items in our scene. So let's just select all of these. Okay, all of these. Now just push them all to the side and make another empty one and put it over here. Okay, that's a nice layout. Now let's just finish the rest. So over here, let's just duplicate our empty counters and place a bunch more. Let's put one more to the side. And now these ones over here, so let's put it over there and rotate it here. And duplicate another one, and another one, and another one, and just one more. And get rid of this one. Okay, great. So here we have pretty much our complete map. Let's also just move the camera a tiny bit, just make sure that it is nicely organized. So put it over there, just so everything is nice and centered. Okay, so there's our map. Now let's get back to working on our delivery counter. We already added this code, so let's just quickly test. So here we are, and if I pick up something like, for example, some cheese, go into the delivery counter and interact, and nope, nothing happens because that one only accepts plates. Now if I pick up a plate, go there, deliver, and yep, there you go, it does work. Okay, great. So this is the basic logic that we want. For defining the actual recipe logic, we're actually only going to do that in the next lecture, but for now, let's add one more nice thing. Let's add a simple custom visual over here using shader graph. This is a great way for you to learn the power of shader graph and just how easy it is to use. This is a visual tool for making shaders. It's really very easy. Personally, I don't know how to write shaders with code, but I can build some pretty nice things using shader graph. As usual, I have a dedicated video on it. I also have an entire playlist showcasing how to make all kinds of interesting effects, and even one special video covering some changes in recent shader graph versions. So over here, let's learn the basics how to use it. So first, here in our project window, let's create a brand new folder. Let's name it just shaders. And now inside, let's create one. So let's create, then go up here into shader graph. Then we're using URP, so let's go inside there. And here we've got a bunch of options. Now don't worry about picking the quote-unquote wrong option. All this does is just create a template. So for example, if you accidentally create an unlit shader, you can then easily swap it out for lit. So right now, let's go with the unlit shader. And for the name, let's name it moving visual. Okay, there's our shader graph file. Now let's just double click to open it. And up here we have the nice shader graph window. By the way, you can make this full screen. So you can either right click over there on the tab and maximize, Or alternatively, you can just click on this window and use the hotkey Shift Space. And yep, there you go, it does maximize. Okay, great. Now, by default, we have this down the center. This is called the master stack. These are the actual properties that we're going to need to use. Then on the left side, we have the properties blackboard. On the right side, we've got the graph inspector. And finally, down here, we've got the main preview. All of these windows can be scaled. And also, if you don't see these windows, or if you accidentally hide them, they're all up here on these three buttons. So the blackboard, that's on the left, the graph inspector, and the main preview. Okay, so now here we've got a nice empty board, so we can add whatever nodes we want. So we can right-click and go into Create Node, and then we can write something, or just click anywhere and press on space, and there you go. Now we can cycle through and browse all of these menus to see all of the nodes that exist. There's tons and tons of them. Or alternatively, just go up here and use the search bar. So for example, let's find the sample texture 2D node. So here it is, this one. Okay, we've got this node. What this one does is it takes a texture and grabs the color from it. So on the left side of the node are the inputs, and on the right side are the outputs. Within the parentheses, you can actually see the types. So for the input texture, this one is of type T2, so that means it's a texture 2D. Then on the output, you can see there's a 4, meaning it contains 4 floats, which in this case refers to the 4 colors. So that's red, green, blue, and alpha. So for an input, we want a texture, so let's set it over here as a property. Let's click on the plus icon, and we've got a whole bunch of types. For texture, we want a texture 2D, so let's go with that. And then for the name, now usually there are 2 standard names. There's one called main text or base map. Main text used to be the more common name, but when working with URP, for some reason they decided to name the main texture as base map. So over here, let's stick within the URP standard and just call this base map. Okay, there's our property, and if we click the selected, and on the right side we can see the graph inspector, and we can see all the properties for this actual property. So we see a name, reference, and a bunch more things. Now the really important one is over here, the reference. This is the actual name that you're going to use if you want to interact with this shader through code. The name on the property, this one is just a text string, so this can be whatever you want. You can even have spaces and so on. Whereas the reference name, this is the really important one. And by default, when you set up a name, it should already set the correct reference. Usually the standard is to name it just like the name, but without any spaces and with an underscore in the beginning. So just like this. Okay, then we can give it a default texture. So let's go ahead and select something. For example, over here, the bread texture. Remember, this is just the default. This will not be hard-coded directly into the shader. We can then modify this. Okay, so we have our nice base map property definition. Now we can just drag it over here on the board, and yep, there it is. And now we can just click on the circle icon in order to drag a connection, and let's connect it over here onto the sample texture to the input. And yep, right away we do see it does work, so we are correctly sampling the texture. However, if you look on the main preview, over here there's still nothing. That's because we don't have this node connect to anything. We need to connect it to the final master stack in order to render something. So again, on the output over here we can see a 4, so these are all of our colors. And actually, one very useful node is the preview, since so many things in shader graph can be hard to visualize. So we can move these nodes around, and let's add the preview node. And this does exactly that, so you can fit it an input, and you can see down here what that input contains. So for example, let's drag just the red channel, and if there you go, over there we can see the red channel for this texture. We can drag the green channel, the blue channel, or look at the alpha channel. Yep, there you go, it does work. So this preview node is super useful for being able to see what your shader is actually doing. Over here we have the colors, so let's get rid of the preview right now. And in order to make it work, we really just need to connect the RGBA and go up here into the base color. And right away it should work, but you might not be able to see anything over here on the main preview. I believe this is a rendering bug in the current tech version, so right now nothing is shown. So if you still don't see anything, it's actually pretty simple. Just go up here on the top left side and make sure to save the asset. Okay, save it, great. Then let's exit from our maximize view. And now let's close this tab. Let's click on play just to play the game. Now let's stop playing. And now if we open the shader again, yep, there you go. Now we do see the shader compiling over there, that color, that is the shader compilation. And after a little bit, it should work. Let's just maximize this. So yep, there you go. There we do see our texture. Okay, great. So again, this is just a simple rendering bug on the current tech version. If you're watching this video in the future, chances are you don't even have this bug, so there's no need to worry. Okay, so right now we do see it working. We can see our bread texture, and it's currently being applied on a sphere. For our use case, we're working with 2D textures, so this would be best to be seen on a quad. So we can right click over here on the preview in order to select the preview mesh. So let's go with a simple quad, and yep, there it is, we have our nice quad. Okay, great. So over here we have our basic shader. All it does is just shows a texture, that's it. Now let's actually use this. And first, let's always make sure to save the asset. On the top left side, on the moving visual, if you see an asterisk here, that means you have unsaved changes. So always make sure to save them. In my case, I don't, but still, never hurts to save. Now over here in scene view, let's go inside our delivery counter, so let's open it. And now for the display for our arrow, let's make it a flat quad. So let's right click in the hierarchy, let's create a new 3D object, and let's make it a quad. Let's call this the delivery arrow. Let's place this on top of the counter, so let's rotate it to face upwards. By the way, on the rotation, make sure the color is facing upwards. Most shaders by default, they only render one face and not the other one. So make sure you put the face with the color upwards and not the other one. Okay, so let's rotate this one upwards. So there you go, 90 over there. And let's just put it just exactly on top of the counter. So just enough so that it's visible. Okay, great. So now let's make a material for our arrow. So let's go inside the materials folder, and over here, let's create a brand new material. Let's call this the delivery arrow. Let's make sure to use this material on the quad. So let's just drag it over there on the mesh render. Okay, so it's using our custom material. And over here on this shader graph drop-down menu, over here we can select what shader we want to use. So in our case, let's go inside the folder shader graphs. And inside, yep, here we have our moving visual shader. So let's go ahead and use this. And yep, right away we do see that it does work. Here we have our texture being drawn exactly on top of our material. Okay, so far so good. Now again here, remember one very important thing that I said. The texture that you define the shader, over here the default for the property, this one is only the default. The important one is the one that we have on the material. I'm emphasizing this point because I've seen a bunch of people make this mistake. If you modify the default texture whilst inside the shader, like for example if I change here from bread, let's say into the cabbage slices, if I modify that, note how it does not modify any materials that were created. We are only changing defaults. So if you want to change the texture that is actually used, make sure you change the one on the material that you created and not the default. I changed the default but did not change this shader. However, if I now were to make another material, which by the way, here's a quick tip, you can right click directly on the shader file and go into create and create new material, and it will automatically create the material using that shader. Actually here, it didn't update default just because I didn't save the shader. So I modified this one for the cabbage slices, and now if I save the asset, and now if I right click there and I create a brand new material, and yep, now that one does have the new default. But again, remember, what you set over here is just the default. What really matters is what is on the material. After the material has been created, modifying the default here does nothing. So always keep that in mind. In most cases, you want to be changing the property on the material itself, not the default on the shader. Okay, let's just clean up both of these. All right, so let's continue. Now here we have our sprite working, okay, except we don't want to show some bread, so let's actually use the proper arrow sprite. So let's select this one. And yep, it does work, it is printing the sprite. However, one obvious thing is that the arrow is not transparent like it should be, so let's solve that. Back in our shader graph, in order to make this a transparent shader, we need to actually go into the graph settings. So in the graph inspector, go into graph settings, and over here you see a bunch of settings that relate to the graph itself and not any selected property. So let's go into graph settings. For example, like I mentioned a while ago, you can modify between lit and so on. So this is where you would change that. You can also up here add multiple targets. So you can create a shader in shader graph and make it work with the universal render pipeline or the high definition render pipeline or the built-in render pipeline. All of those are supported through shader graph. Now for our goal, in order to make this a transparent shader, let's just go over here onto surface type. Instead of opaque, let's change to transparent. And as soon as we do, look what happens there. And if there you go, it adds a brand new alpha channel. If we just save the asset right now, and nope, look at that, it still doesn't work. It's still not transparent. Basically, we made this shader transparent, but now we need to feed in the transparent channel over here onto the alpha. This is the one thing that is different from a previous version of shader graph. Previously, you could just feed the alpha channel over here onto the base color, and shader graph would automatically apply it. But in recent versions, you need to add it over here separately. So if you have any issues with transparency when following some older shader graph tutorials, always remember this change. I covered that along with some other changes in a very useful video. So if you're following along some older shader graph tutorials, make sure you watch that video to learn what you need to do to update them to the latest version. Okay, so here on the symbol and texture, we already have the alpha channel, so we just connect this onto the master alpha. And right there, we already see it working. Let's just go ahead, save our asset. And here in scene view, yep, there you go, now we do see our arrow. Now, one more small thing. You might notice that from some angles, it's not exactly transparent. Basically, it actually is transparent, but since we made this a lit shader, sometimes the light might make the transparent parts visible. One option to solve that is over here on the graph settings. Instead of making it lit, let's make it unlit. That would work. So yep, with the unlit shader, the transparency is perfect. But if you really want to keep it lit, then the other thing you can do is just over here play around with these settings. You've got smoothness, AO, and so on,